Welcome back to another video on NuttX Continuous Integration or NuttX CI. In the last video, we spoke about this NuttX monitor here. We added some changes since then. Notice that this bar on top in Christmas colors, green and red, it shows us the jobs that have been recently running. Over here, we see that these are jobs that run. But these are jobs corresponding to the PRs. So we list out the PRs here, how long they've been running. Some jobs are longer than others. For example, this job took a long time to run. Normally we expect 3.5 hours. This job took an extra long time to run, 7 hours, because it was waiting for GitHub runners. Apparently, we were short of GitHub runners during certain periods this week, so our jobs couldn't get started. That's why this particular job waited a long time, maybe 4 hours before the job actually started. Good thing is that we are not being charged for this. This will not count towards the Apache NuttX project, even though it took 7 hours, 7.5 hours. Most of the time was spent waiting for GitHub runners, and that waiting time was not charged to our project. Why is it waiting so long for GitHub runner? Well, we suspect that some other Apache project is using our GitHub runners. That's why it couldn't start. Remember that our GitHub runners are pooled across all Apache projects. If some other project in Apache decides to take too many GitHub runners, they will deprive us of our GitHub runners. That's why we have to be really good about using GitHub runners. Make sure that we don't overuse GitHub runners, because that will affect other projects, as what we've seen here. The status here are color-coded. We see that green means that the job was successful. We also see that red means that the job failed. And at the bottom below, we have a little warning if we exceed too many builds for this project. Right now, if we exceed 10 or more builds, we will flag out as a warning here. This is because earlier when we checked out some of the expensive PRs during our peak period in January and February 2026, we realized that some PRs were going through lots of rebuilds because our developers were pushing new commits to our NuttX repo. But moving ahead, we shouldn't allow so many of pushing or rebuilds. We should encourage all developers to use this new way of building and testing the PRs in their own repos, using this way, the manual NuttX CI, which means that we should no longer expect to see too many rebuilds and taking out too many GitHub runners. Yeah. What's not visible here is that if a job is running, you will see this in orange. So orange means that it's running. Green means that it has completed successfully. Red means that it failed. Why did we put this color bar here? That's because when we're looking at this log here, there are some things that were not quite obvious. For example, we see errors and warnings. But what about the builds that have succeeded? We won't know if a build has succeeded by looking at the log here. That's why we put in this bar here to indicate in green those builds that have succeeded. So instead of waiting forever for our job to appear in our log here, we just simply watch this bar on top. This bar shows the latest builds for the past 2 days. It becomes a lot simpler to see what are the builds that are running our system. Also, with this single bar, we can monitor our build times, make sure that they complete reasonably within 3.5 hours. Anything beyond 7 hours, we flag out as an alert. These are things that we need to watch out for and understand why this is happening. Also, if we see too many builds happening to a particular PR, we need to go in and figure out what's going on. Moving ahead, we might have to ask the developer to switch the PR into draft mode. Then I will run a script which will scan for these draft PRs and any builds that they trigger. If it sees that a PR is in draft mode and this draft PR is triggering a build, our script will cancel that build, meaning that draft builds will not contribute towards our usage of GitHub runners. Moving ahead, that's how we're going to manage our GitHub runners. This whole build monitor is now running as a background process in our NuttX dashboard. In an earlier video, we talked about the NuttX dashboard running on a cloud server. This is running on Google Cloud. Since we have a cloud server, we might as well run this on our cloud server, the job that populates and updates the NuttX Build Monitor. Notice that it's running on a tmux session, meaning that if I disconnect the session, it will keep running in the background. Right? This will run forever and ever, 24/7, and you'll keep updating the NuttX Build dashboard. So far, we'll see that it's been updating every 5 minutes or so. Yeah, and it works pretty okay. Now, back to our original purpose, why we created the NuttX Build Monitor. One of the reasons why we created this NuttX Build Monitor is to help us in our testing of our CI build retry. And the idea is that we have this job that will do a retry of CI builds if it fails. This is meant to solve the downloading problem. But the downloading problem is extremely hard to reproduce. And even if you can reproduce it, it's very difficult to scan through logs one by one to discover what failed and whether the retry was working. Thankfully, we have this now. And the results are very obvious. We could really see builds that were failing due to download errors. So, for example, this is a build that's failing due to download error. However, this is not part of our testing, so therefore there's no retry going on. But we see other builds that have failed during our testing, and it's doing retry. The PR that's doing this, now you can see that it's running in orange. I just triggered a rebuild, and now it's doing its own test again. The PR number is 18576. If I do a search for 18576, we can see these are the messages coming from our job. And we see one download error here, and another one here. But let's take a look at this. Now, let's see what happened here. If we scroll up to the top, we see that there's a build of 10.1.8. So it tries altogether 8 times. It's a bit excessive, but I'll explain why in a while. Actually, it starts here. Build a 10.1.8. In the first attempt, it tries to download libmetal.zip, which is part of the OpenAMP library. What is this OpenAMP library about, and why is it using libmetal? This is a QEMU target. QEMU is the emulator. When we run NuttX inside QEMU, it will need services like networking or the disk storage devices. For NuttX to communicate to QEMU about network and disk I/O matters, it uses OpenAMP library. OpenAMP stands for Open Asymmetric Multiprocessing Library. Inside OAP library comes with this libmetal library that will manage the messaging. Yeah, OpenAMP is here. What this says is that it's trying to download the libmetal.zip from the OpenAMP library, and it failed. Our retry script helpfully builds a second time. And notice the exponential backoff. Rightfully, there should be a 60-second backoff for the first retry, but we do a randomized backoff, so it actually waited 58 seconds. The second attempt, it tried, and it failed again, right? Which is good. This proves our point that one retry is not good enough. We need to try a few times. But how many times do we need to retry? Well, we have to do this testing and find out. The second attempt failed. What about the third attempt? The third attempt happened here, and it succeeded. Wait, did it? No. Something else was messed up here. It took actually 4 attempts. This is the 4th attempt, and everything succeeded. Therefore, our retry mechanism is working, although it took 4 attempts to get it to work. And we can see that the wait amount is getting bigger and bigger. Right now, just before the 4th attempt, it waited 103 seconds. That's a randomized number between 0 and 240, which is exponential backoff. This proves that our retry mechanism is working, and we are continue to watch for more of these cases to get more evidence that it's working. Just in case that there's some particular download that doesn't work so well with our exponential backoff, we'll find out. And that's what our NuttX Build is good for. We are able to find these kind of things in our logs so that we can validate whether our retry mechanism is working fine. And it works great so far. So we'll keep monitoring. We have been looking at these download errors, filtering through them. We see at least 4 attempts so far. Just now we saw libmetal, part of the open AMP library, and we saw that it succeeded after 4 attempts. Then we see other libraries having the same problem. This is LLVM library with libc++. This was okay after 2 attempts. ESP32 extensor build was downloading something from code load. We're not sure what exactly is downloaded. The URL and the zip file wasn't visible. It was okay after 3 attempts. And we see also this NES Labs /NL unit test. It seems to be some kind of probably some kind of a communication protocol, some mesh protocol, for example. It was successful after 2 attempts. We'll keep collecting these test results. At this point in time, it looks very encouraging. We have detected 4 download failures, and our CI retry mechanism succeeded on all these 4 downloads. And none of these exceeded 8 attempts. All of them finished within 2, 3, or 4 attempts. There have been cases where we saw quite a bit of retries. Let me show you this. Inside our documentation for the CI build retry under NuttX issues, I've documented this single case where, yes, it was downloading LittleFS, the LittleFS file system for embedded systems. It succeeded at the 3rd attempt. Then it tried to download this arc table thing, not sure what it's for. It succeeded on the 2nd attempt. And then it tried to download libmetal. And we realized that after 6 attempts, it still failed, which is why I switched my code to do 8 attempts. Maybe if we hit this situation again, 8 attempts might be sufficient. But then we have a problem. 8 attempts is a long time. If we look at now we're running this test to see what happens under a compile error. Remember that our retry mechanism does not know why it failed. It will retry the build no matter why it failed, no matter the reason for the build failure. It could be a compile error, it could be a download error. Regardless of any error, it will always retry. Therefore, we have to make sure that we test it against all kinds of errors, like a compile error, and make sure that our script behaves sensibly. Now, notice that our build started around 10:50. This is the 1st attempt. We simulated a compile error. The compile error failed. Our retry mechanism is very, very straightforward. It will just simply retry. It will do a backoff and it will try again. And now this 10:51 for attempt 2. If we move on to attempt 3, 10:53, 55, 56, 11:02, 11:20, and finally 11:32, and finishing up at the next build is at 11:33. So we took 33 plus 10 minutes. That's actually there's more than that. 33 plus 10 minutes. That's over 40 minutes of time on one single build. Because our retry script is quite naive. It doesn't know why it failed. Even if it hits a compile error, which we know that will not fix by retrying, it will keep retrying. And we wasted over 40 minutes, 40 or 50 minutes just on this one single build. And this happens. It happens because why did it take so long? Because exponential backoff. Notice that the backoff keeps doubling up quite a bit. The exponential backoff will add up. Every time we retry, we will double the backoff time. Well, randomized than backoff, which is not so good. We have wasted 40 minutes of our build. It will be charged to our GitHub runners time. Therefore, we may need to tune this value down. If through our experience we see that most, let's say 90% of our retries are okay after 4 attempts. Let's say that at most it takes 4 attempts to fix our download issue. Then we'll tune this number from 8 down to 4. That way we conserve our GitHub runners. And the other good reason is that our developers are waiting. We don't want them to wait 40 minutes to discover that the build failed. Then again, having the retry mechanism is a really good reason to push our developers to go towards this manual NuttX CI, to build and test PRs in our own repos before pushing into the NuttX repo. Here's something else that we're testing. Notice that after we do our last builds, we give up, right? Now, notice that this was build 808, and then we switch on to build 101. We kind of reset the maximum retries. Earlier on, we were retrying up to 8 times, but if we really fail, we will retry up to once. Why are we doing this? Well, it's because of this situation. If it's a compile error, we do not want to reattempt the next thing for eight attempts, because it will just take too long. And also we are concerned that some errors may be cascading, like say config errors. If this thing fails, everything else also fails around it. If everything also waits 8 retries, 8 attempts for 40 minutes, that's going to be a very, very long job. That's why we reset a timer, reset the max attempts. If this thing really fails and we give up, we will reset the max tries to 1 instead of 8. I simulated another error down below here for PinePhone. Do you see it? Okay, here is another error that I simulated in PinePhone NSH. Notice that the max attempts is working. Right now we're doing only one attempt maximum. If this thing fails, we do not retry. See, it goes on to the next target, build attempt 101, which is good. Which means that our developers don't have to wait too long for this job to finish, because right now it will just give up. It will not attempt any retry. That's why the initial number is quite important. Should we build up to 8 times? Should we build up to 4 times or 2 times and so on? This will depend on our testing. If we give up too soon, let's say if we give up only after 3 times, then there'll be times where it requires 4 attempts and it's not sufficient. Right now, I'm thinking that based on this data alone, I may just set the maximum at 4. We will not retry after 4 attempts. That means 1 build plus 3 retries. But let me collect more data from our NuttX Build Monitor, and we'll see whether it can tell us what is the maximum reasonable number of builds that we should do for NuttX. Right, and we see a new job just started here. Okay, this concludes my presentation for the NuttX Build Monitor and how we are using it to test our retry mechanism. So far, we're getting very good results. We have been seeing successes in the way that it handles rebuilds and it fixes the download issue. After reattempting a couple of times, like say 4 attempts, it will actually re-download correctly. So it's good to know that it's not a persistent issue. Downloads can be fixed through retries. However, we are concerned about compile errors. Compile errors might wait too long if we have too many attempts. Right now, we are collecting data to see what is the maximum number of attempts that we should configure in our script. And NuttX Build Monitor will continue running. It's now running on the cloud at Google Cloud. It will continue running for next couple of weeks, and it will run while I'm away. That's because tomorrow I'll be running a half marathon. Then next week I'm flying overseas to run a full marathon. That's 42 kilometers. And this thing will continue to run even as I'm running my half marathon and my full marathon. Hopefully by the end of the full marathon, I should have a lot more data, and we will then be able to decide whether we should push this through to production and implement CI build retry for good. Thank you so much, and I'll see you in the next video.